Hello everyone, welcome to my next tutorial of the last series. In this tutorial we are going to discuss and simulate about the PV simulations with the metal grid geometry. So before we start off this tutorial, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. About the company and their feature we have already discussed in our previous video. So who has not seen it previous video, set first as well as large software, so they are available on this platform and their playlists are also available, so please check out. And how we can use large softwares and how we can import geometry we have already seen our previous video. So first I will see that's presentations parts that we are going to simulate in here. PV device with the metal grid. This type of structures we will be create in the lever cuts, and you can also use large softwares to create this type of geometry, but we will be preferred to use lever cuts, so you can use different type of geometry. Lever cut is generally freely tools, so you can use. In here we will be enhance the conductivity of the transparent electrode, and we will be see different voltage losses and other features that we can simulate in the large software. So now we are going to start large softwares and how we can create that geometry. So first we will be create the geometry in the lever cut, then that geometry we will import on the large software. We will be open lever cuts and prefer to create that same type of geometry in these tutorials. We are just follow that tutorials. That geometry of the last tutorials you can see, we will be create the same geometry on the lever cut tools. As first you can see in here 18 mm, and it is the same 18 mm, so it is a vertical lines, and 2 mm it is a horizontal line, and 1 mm. So then we will be create in here the metal fingers you can see. So now we need to follow that same procedure. In here click on the snap in points, and then you can go with this vertical lines and select in here one, and then you can move with this point and click. You can see that it is a 1 mm. You can see in here option their defaults. We have already selected in here mm, so I have not selected, so please select mm. So it is a 1 mm vertical line. Now we need to again draw in here that 17 mm line, so select in here the 17 mm and click on the snap on the end point and click like this. You can see it is a 1 mm line and it is a 17 mm line. Now we need to draw in here the 2 mm horizontal line. Select horizontal, select in here the 2 mm and click. So it is a 2 mm line. Now we again click in here the 1 mm vertical line, so click like this, and then 17 mm vertical line. Now you need to again draw in here the 2 mm horizontal line, so select horizontal and click like this. So you can see that type of geometry, but you also need to create in here that metal finger also. As per this you can see it is a 0.9 mm and 0.9 mm, and you can see it is a 15 mm. Select in here that's 0.9 and select in here that's horizontal, click like this. Now for this you need to rotate, so select horizontal, select angle also. You need to move with this angle 0.9 like this. You can select in here the minus 180, so it will rotate. Now you need to again select in here the vertical and 15 like this, and select horizontal, select 0.2 like this. So you can see that geometry have been completed in here. The same parts you can see. You can also give in here the points, but is not mandatory in here. Now you can save that project file, PV simulations file, and click on that save button. Now you can open that large softwares, run as administrator, click on the yes. So it is a GUI of the large software. We have already discussed about their GUI first and second video, and we have already see how we can import geometry. So apply that same process, import geometry and load from files. Click on the plus button, download, and you can see PV simulations file. You can click apply and OK. So that type of geometry we have imported in here, and you can see in here the status have already completed. We not need to change anything in here. Boundary conditions, subdomain, you can give in here the subdomains, inner subdomains if you want to give. In a import geometry video we have already discussed. Now we can give in here that boundary conditions each first, each second, each third, and each fourth. Create boundary conditions. So first you need to select one each first and click on the OK. You can see one boundary conditions have completed in here, and hold the shift buttons and create another boundary condition each second. Then give the name each third, create boundary conditions each third. After each 3 you can select each 4 like this, give the name each 4 and click on the OK. It is a default, but you can also give in here the middle finger subdomains part. So create in here the another, add subdomains. First we need to select lines like this and add subdomain middle finger and click on the OK. Add area. This is a default and this is the middle fingers. So you can use that steps as well as defaults and middle fingers. Now you can use this geometry and give in here your project name like PV module simulation example and click on that OK. So you can see in here the DSF geometry files. So if you want to create in here your own rectangle metal fingers, you can use these tabs and you can create directly. And unit we need to select in here the and this is the missing tools next generation and BAMG. About that missing tools you can cut there the geometry shapes. Refining factors you can also see in here. It will help to get accurate results, so you can use. To click on the run missings, you can see number of the vertex, number of the elements. You can use these tabs for the run missing. And we have already aware about these things as metal finger has width 0.2 mm, so each size have to small for the good results. So you need to remember that you don't need to run that missings. You can directly work on these geometry files and you can select in here the single electrodes as per the default you can see, and metal finger you can see, and you can see in here the electrical couplings. So ohm, mod different coupling are given in here. So you can see how we can import their JV curve, JVT curves, and set for simulations files, set for simulation with the JVT. And you need to select in here the imported JV and move with these tabs. You can see in here the log. In the lower softwares you can also import their geometry 0.9 mm. I'm going to show you. You can see in the local disk. See, you can import that metal finger 0.mm DSF files. So it is the same. So in the last examples that file are also available, but in here we have imported directly. You can move with this part. You need to import in the default JV curve perovskite slide diode mode fit. So select this and click on the open. You can see units and current density, unit of luminance they have already selected in here. You can click on this apply and click on that graph tabs. Same for the metal fingers. Move with the imported JV, load, and in here you need to select JV perovskite dark metal dot mode fit and then click on the apply and then click on that graph. So it for the metal finger and it for the default. So you can see now you need to move with the electrode tabs. In the default you can give in here the seat resistance value. That value we need to enter in here the 20 ohm. You can see in here the different parameters for the resistance are given. You can select any parameters according to the your choice and your projects. So we have selected in here just one of the example value, and now we need to select in here the 0.16 metal finger seat resistance. It corresponds 6.7 copper conductivity generally you can see, and in here you can see the pedot conductivity. At the next you can move with the boundary conditions. You can see each tops, each second, each third, each fourth. So we have selected different shapes, so you can choose any one of these. You can select that each and their boundary conditions. You can see this is the top, so you can choose in here the voltage and they have automatically selected in the zero value. In here it is the same current each and their value. It is the current that have selected zero. You can move with this shift tabs. You can vary in here that parameter as well as set first you have done in here. You can same procedure you can follow. Full module handling if you want to do, you can use, but you need to enable that setting. Click on the plus button and you can see here the different parameters are given. You can check if you have selected that thermal, so you can select this parameter also, frequency, and set first parameter. If you imported one of the set first projects, so you can use. In here you need to select that boundary conditions potential. Click on this potential, edit. You can select only the each first, because in the boundary conditions you have selected only each first boundary, and voltage we are going to vary it in here the potential, so only select each first. And click on that edit tabs. You can choose linear, log, tabular form. So if you select log, you can also import, create tables, load CSV files. So it totally depends on you which type of setting that you want. 0.1 and skip step, that step you need want to select in here. You can select in here 1.2. You can select in here the step 0.1. Click on that OK. So geometry machine, device IVT, and electrode boundary conditions, and shift that settings we have already selected in here, and it is a fit or optimize tab. So if you want to use these tabs, you can also use solver. Convergence criteria totally depend on that simulated parameters, which type of project you have simulated. So according to you can select, so it will help to get the accurate result. So absolute, residual, normal, RMS, and in here the tolerance value you can select 10, and maximum number of iteration you can select 20. We have already discussed about this. It will help to get the accurate or correct formats or correct results. So now you can run your project. Now you can see your results, simulations, and ohmic losses diagrams, source power diagrams. You can see near that value, maximum power points, linear interpolated value, and spline interpolated value, maximum power per area, open circuit voltage, short circuit currents, fill factors. So you can check one by one each of that value, total power diagrams, diagram per subdomains, electrodes, and you can see near the flux per boundary conditions for the 0 volts, global per value subdomains. You can check in here one by one. You can see. You can also check in here the source current density top electrode, ohmic loss top electrode, source power top electrodes. So that type of results you can see. If you want to compare with the total device current diagram with imported JV curve, you can click on the keep diagrams and diagram per subdomain metal fingers, and you can compare with the total device current diagram. If you click on that cape diagram, same for that per subdomain electrodes, and it for the flux boundary conditions, you can compare like this. Now I'm going to end here my tutorials. You can see how you can simulate your projects with metal fingers. In the next video we will see the optimization tools, how we can extract our parameters with the same geometry. So anyone have that query, so please ask in the comment box, and you can also mail, because email are also given on the end of the video as well as the description box. And who has not seen it my previous video, please check out the playlist. Thank you very much.